You know, in the world of scientific research, there's this quiet revolution going on. It's a shift that's all about access, collaboration, and one absolutely brilliant piece of open source software. Today, we're going to dive into the rise of new Octave.
But before we get into that, let's just start with a really big question. I mean, think about all the breakthroughs and discoveries we rely on every day. What if the very tools you need to make them happen are locked behind these massive paywalls? Could the cost of software actually be a bottleneck for scientific progress?
Well, it looks like a whole lot of researchers think so, because they're already finding a new path forward. They're starting to move away from the traditional, super costly software, and they're doing it because they need tools that are way more accessible, more flexible, and honestly, more collaborative.
And this is where the hero of our story steps in, GNU Octave. This is the powerful, open-source challenger that's stepping right into the ring.
So what is this thing really? Well, the easiest way to think about it is like a supercalculator for scientists. It's a programming language that's built from the ground up for complex math. You know, the really heavy-duty numerical stuff you need for simulations and data analysis?
Okay, so who is this for? Well, it is an absolute game changer for students who are just learning the ropes, for researchers working on a really tight budget, and for data scientists who need a seriously powerful tool without that hefty price tag. It's all about empowering innovation, whether you have a massive budget or, basically nothing.
All right, but for Octave to be a real challenger, it has to go toe-to-toe with the undisputed champion, right? We're talking about MATLAB. So let's take a look and see how these two actually stack up in some real-world research situations.
First up, numerical simulations. Building these incredibly complex models of real-world systems. Now, MATLAB is famous for its rock-solid performance, for sure. But Octave delivers some serious performance with a critical advantage. Its syntax is almost identical. This means researchers can just switch their existing code over with very few changes, saving who knows how many hours of work. I mean, that is a huge deal.
Okay, next up, signal processing. This is where Octave really shows off its secret weapon, flexibility. MATLAB has incredible tools, no doubt. But with Octave, because it's open source, researchers can actually pop the hood and tinker with the engine. They can tweak algorithms and experiment in ways you just can't with proprietary software. And that's where true innovation comes from.
And that kind of flexibility, it's absolutely vital when you're prototyping algorithms. When you're trying to invent something new, you have to move fast. Now, Octave's compatibility with MATLAB helps a ton, but the real engine here is its community. New tools and features are being added constantly, and they're often built by the very scientists who need them for their own cutting-edge projects.
And finally, let's talk data modeling. Look, both of these are powerhouses, but Octave delivers what our sources call a significant cost-performance advantage. And this isn't just about saving a few bucks. It's about totally leveling the playing field. It's about giving researchers and labs with less funding or in emerging economies the exact same powerful tools as everybody else. So, okay, technically, Octave can clearly hold its own. But the real story here, the reason this whole shift is picking up speed, it goes way beyond just performance specs. It's about the unique superpowers you only get with the open source model. And really, it all starts right here, with this number, 0. A big, beautiful 0. No expensive licenses, no annual renewal fees breathing down your neck. This one thing completely removes one of the biggest roadblocks to doing high-level scientific research. But free is just the beginning. The true power of Octave is its amazing, vibrant community. I mean, this isn't some piece of software that's just handed down from on high by a big corporation. It's a living, breathing project. The users are also the creators. They're the ones driving innovation, sharing what they know, and building new tools for everyone else to use. It's this incredible cycle of collaborative improvement. And just look at how perfectly it slots into a modern research workflow. A researcher today might collect some data, use a tool like Python for their first pass analysis, and then pivot right over to Octave for the heavy-duty numerical simulations before sharing all their results through the cloud. You see, Octave isn't just a replacement, it's a key piece in a much larger, way more flexible toolkit.
So when you step back and look at the big picture, what does all this really mean? Well, this isn't just a story about one piece of software. It's about a fundamental change in how science actually gets done. The future of discovery is, well, it's open.
There's a quote from our source material that just hits the nail on the head. This democratization of technology,
That's what it's all about. It's making sure that a brilliant idea, no matter where it comes from in the world, has a real chance to grow without being stopped by financial barriers.
So at the end of the day, here's what it all boils down to. The rise of tools like GNU Octave is about so much more than saving money. It is about unleashing human potential. It's about empowering more brilliant minds all over the world to work on our most complex challenges, everything from climate change to medicine.
Which really just leaves us with this one final and honestly pretty exciting question to chew on. As these open, collaborative tools become the new standard, how are they going to fundamentally change the speed, the scope, and maybe even the very nature of scientific discovery itself? The revolution? Well, it's already here.